All right, let's get right into it. Today, we're talking about something huge, something really fundamental, the nature of math itself, and why it's so, well, why it's always right.
And it all kicks off with a question that, seems almost too simple, maybe a little childish. But really think about it for a second. Why does 1 plus 1 always equal 2? Every single time. No matter where you are, no matter when you are, it just is. Why?
The crazy thing is, we absolutely depend on this perfect, unshakable stability all the time. I mean, it doesn't matter if you're just adding up your groceries or if you're an astrophysicist charting the course of a star billions of light years away. Math is the bedrock. It's the foundation for literally all of science. But where does it get this incredible power, this unbreakable solidity?
Well, there's a pretty radical hypothesis out there that offers an answer. And honestly, it might just change the way you look at, well, everything. It's called the ERM hypothesis. And here's the core idea, in a nutshell. Math isn't something we humans invented. Nope, it's something we discovered. This idea says that the rules of algebra aren't just clever human tricks. They're the most fundamental, stable patterns that reality itself can even form.
Now, to really get this, we need to wrap our heads around a key term, attractor. An attractor is just a state of stability that a system naturally falls into. And the best way to picture this, think about a river.
So how does this whole finding stability thing actually work in practice? To really get what this hypothesis is saying, we've got to try and visualize how the universe itself finds its groove, how it settles into a pattern.
And this is the perfect way to think about it. Imagine a river over thousands of years. It tries out countless paths, right? There's flooding, chaos, new routes getting carved out. But no matter what, the water eventually finds its way back to that one deepest, most stable channel. That channel, that's the attractor.
So the whole process looks kind of like this. First, you've got a ton of different possibilities, a whole lot of chaos and turbulence. But give it time, and the system just settles down. It finds the most stable, most efficient path. And once it finds it, boom, it sticks. The attractor is formed.
Here's another amazing way to picture it. Think of a mathematical law as being like a perfect whirlpool in a giant cosmic ocean. It's a pattern so perfectly stable, so self-contained that it just keeps going, completely immune to all the chaos swirling around it.
Okay, so rivers, whirlpools, cool analogies. But what does any of this actually have to do with algebra? Let's connect these big ideas directly to the math you might remember from school.
Take a look at this. It's a simple little rule from a part of math called group theory. All it really says is that if you take something and combine it with its exact opposite, its inverse, you always get back to a neutral starting point. Now, that's not just a rule we made up. It's a perfect, self-contained logical loop. This is the mathematical whirlpool we were just talking about.
Or what about this? The inverse of an inverse is the original thing, right? You make a U-turn, then you make another U-turn, you're going back the way you started. This hypothesis argues that's not just a clever observation. That's a logical orbit that is as fundamental and stable as a planet's orbit around the sun. It can't be any other way.
And that brings us to the main event, the big comparison. On one side, you've got the idea that math is just a tool we invented, with arbitrary rules that we just decided on. It could have been different. But this hypothesis, it says the exact opposite. It says math is a feature of reality we found, like discovering a new continent. Its laws are natural, they're self-consistent, and they are completely, utterly inevitable.
So where does this all lead? Well, it leads to a final revelation that is, frankly, pretty mind-bending. Because if these perfect logical loops, these rules of algebra, are the most stable things that can possibly exist, then they aren't just describing the universe. In a very real way, they are the universe. They're the fundamental framework, the skeleton of coherence that gives reality its structure in the first place.
To put it another way, think of it like this. The laws of algebra are the universe's oldest, deepest memories. They are the very first, most perfect patterns that stabilized out of the chaos, becoming the silent, unshakable foundation for everything else. Which leaves us with one last, big question to think about. If math really is the fundamental grammar of being, then what amazing stories is the universe telling us with it?